Today we are going to do the hypothesis testing for variance. As we know, you may have one population and you take a sample from this population and you would like to test the variance of this population greater than or less than or equal to a specific value, right? So you will go for one sample variance test. In this case, you are using chi-square test for one sample variance, right? If you have two population and you get one sample from each one, so you have two sample and you would like to compare the variance of the two population. In this case, you go for F test, right? Let's go for this example. Do we have one sample or two sample? From this data, it is only one sample, right? Okay, so as we have done in the hypothesis testing for means, we have 5 steps, right? Let's do this one. Okay. I'll take my board here. Okay. So, first of all, the first step, we are write the test, right? So what's our test? What is the name of our test? If you don't know, yes, just go back for this one. You have one sample, so you go for chi-square test, right? Okay. So the right test is one sample because we know we are going to do what? Yes, the claim, the standard deviation. Once I heard a question about the standard deviation or the variance, I'm thinking about chi-square if I have one sample, F test if I have two samples, right? So as far as I see here, I have one sample and the question about the standard deviation, right? So the test is what? Using chi-square test for the population, for the variance, sorry. So what is the steps? Okay, the step 1, we just write the hypothesis, right? Step 1, just write the hypothesis. I have two hypotheses. One, I call it null hypothesis, and the other one, I call it the alternative hypothesis. The null hypothesis is almost with equal, right? So I'm saying I have one sample, so I am saying the standard deviation of the population equal to what? He said here greater than 8, but the null hypothesis is talking about equality. But the alternative is the claim, right? So you say sigma, because you have keywords here greater than, so it will be a right tail test. So once I have this one, so I'm calling this one right tail test. Very good. I finished the first step. I'll go for step 2. In step 2, I have to know the level of significance. The level of significance equal to what in your question here? Guys?
.10.
Yes. Right. Okay, so the level of significance alpha equal to 0.10. Okay. So what is the critical value? And I have right tail. Remember, I have a right tail. So I have only one critical value. So the critical value is, yes, chi-square need what? Need a degree of freedom, right? And alpha. Okay. So I'm looking for in the table for chi-square for what is the degree of freedom. Most of time, the degree of freedom is all the time the sample size minus 1. So what is the sample size in this case? He gave you 15 days here. If you count this one, 1, 2, 3 times 5 will be 15. So the degree of freedom will be 15 minus 1. It will be what? 40. Good. So in the table, you go for chi-square for degree of freedom 14 and alpha 0.10. Okay. We know how to use the table for chi-square. So you go for degree of freedom. Okay, and go for 14 and go here until you reach 0.10 for what? For one tail. This is how to use. Let's go for the table and see what we have. Okay. So I will go for 14 as a degree of freedom and go horizontally until I reach alpha equal to what? 0.10. If you have the other chi-square test for one tail or two tail, your test is right tail, so it is one tail for alpha. So what is the value? 21.064. Very good. So we know how to use a chi-square distribution. Now I'll go for step 3. Step 3 is need a calculation. And depend on the formula. What is the formula here? The stat value coming from the formula chi-square equal to n minus 1 times the variance of the n minus 1 times the variance of the sample over the variance of the population. I know the variance of the population is given. Yes, it is given, but it gives you what? It gives you the standard deviation. It gives you the standard deviation equal to what? 8, right? So this is the what? This is the standard deviation. So I have to square it. So it is n minus 1. N is 15 minus 1 times 8 square over, over 8 square. But how I can get s square? Yes, do you have your calculator? Guys?
Yes, doctor.
Go for
Yes,
mode.
Doctor.
To do this one, go for mode.
Okay.
Go for equation, for stat. Go for one variable. It give you a column X here. Let's input our data. So I'll bring my calculator as well. Sorry, I don't have it here. Okay. You input 25 and press equal. 42 and press equal. Anyone guys do it for me?
Yeah, doctor, I'm with you.
12 equal, 30 equal, 16 equal, 38 equal, 5 equal, 9 equal, 8 equal, 15 equal, 10 equal, 14 equal, 18 equal, 12 equal, 27. Now you input all of your data, right? You finish it?
Yes, doctor.
Okay,
Yes,
so
doctor.
after this one, you press AC, right?
Yes.
And then shift and 1. Why 1? Because you have stats here. And now you have a window. Go for one variable. He will go open another window for you. You are looking for sx squared, right? Sx. He gave you only sx. So you get sx equal to what from your calculator?
11.20.
11.20.
20.
Thank you. So you're still looking for chi squared stat from the formula n minus 1 times s square over sigma square. Sigma square is the population variance. It gives you the standard deviation, so you have to square it. N, the sample size, is 15 minus 1. S, you get it from using your calculator. Can you find the result of this one, please?
Doctor, 27.44.
27.44. Okay. I'm coming back and I know this is what? This is a right tail, okay? So in step 4, to have a decision, in step 4, make a decision. And I know from step 1, I know it is right tail, right? Right tail test. So I'm just sketching this little curve like that. Okay, and I have a right tail, so I have here. So this is 0.10, this area. Okay, so and my critical value was what? My critical value was 21.064. 21.064. This is the chi-square critical, right? What's my stat? My stat is 27, right? So the 27 will be over here, right? So I'll just make it clear. Here is the chi-square test, chi-square value, which is 21. Yeah, 21.64. 0.64, and I have calculated the stat value, which is chi-square stat. It was 27.44. So the stat value lying in the rejection area, right? This is the rejection area. Rejection area. Rejection area for what? For rejecting the null hypothesis. So because the chi-square stat is bigger than a chi-square critical, it means it lies in the rejection area. In the rejection area. So what? So we reject. This is our decision now. We reject H naught. What's H naught? H naught saying sigma square equal to 8 square, right? Or if you would like to write it only sigma, so no need to square it. So we reject this one and accept the other one. If you reject H naught, you have to accept the alternative one. Sigma is greater than 8. Now we would like to write step 4 as a summary, right? In step 5. So the summary is what? Yes, there is. Okay, sorry. A significance. Evidence that the standard deviation is greater than 8. That's it. Sorry, just 1 minute. I'll bring a charger. You catch it? Okay. Now, this is exactly the 5 steps we have done. We are writing this one, and we get the same value from the table. Okay. And next, we got the stat value from the formula of the chi-square for one sample variance. Okay, and almost the same. Next, we judge the stat value with the critical value by sketching this nice one. Why make it right tail? We make it right tail from the step 1. We have the alternative hypothesis greater than. So right tail, left tail, two tail depends on the alternative hypothesis, right? Okay, now the start value lying in the rejection area of the null hypothesis. So we reject the null hypothesis. Once we reject the null hypothesis, we accept the other one. So the other one saying what? The standard deviation is greater than 8. So there is enough evidence to support the claim that the standard deviation is greater than 8. Okay. Let's go for this other example. You would like to answer the question using 10% significance level. We would like to see there is a difference in the variation. Variation means variance, right? Okay. In diving times. So you have two samples from two different population. You would like to compare the variation, or in statistical concept, the variance between the population of US routes and interstate 75 routes. Okay, is the same. If you go for Excel, let's do it by the Excel. Can you do it with me, please? Okay. We input this one in the table. So anywhere I can write US route 25 in a column and make it bigger, slightly bigger. And we have the other route, interstate data, 75 data in this one. Let's input the data, 52, 67, 56, 45, 70, 54, 64. Once you finish this one, we go to input the other sample, 59, 60, 61, 51, 56, 3, 57, 64. Now we input the data, okay, and just make it nice and cool. Okay. Now, how to use the F test? Because I have to sample, I go for data, I go for data analysis. And if I come to here, I will not find chi-square for variance. Okay, I don't have chi-square at all in the Excel, right? But I have only F test to sample for variance. This is the one I compared the two sample variance using F-test. Okay. Now I input the first sample. Remember, don't go through the empty one, right? Next, I input the second sample. I have a label because I have names in the beginning of the column. I have, no, this is not 5% in this time. It is 10%, right? I would like to have the result in the same sheet. So don't forget to put the mouse over here, and anywhere you can put this one and you will get the result right now. Okay. Now I have the result. How to read this result, right? In the beginning, he give you some descriptive statistics like a mean. This is the one, the variance we already get. You can calculate it by the calculator. Observation, it means the sample size, right? So in the first sample, we have 7. 1, 2, 3, 4, 5, 6, 7. In the other one, we have 8. Okay, so the degree of freedom of the first one is the sample size of the first one minus 1. And the degree of freedom is 7. So we have 2 degrees of freedom in F. Okay, this is what? This is the stat value, right? Yes, so I will shade this one. I call it the stat value. This is what? The F stat. Now I have to decide it. Shall I go for one sample, one tail, or two tail? Okay, all the time you have F for one tail in this case, right? Okay, so you would like to say that this one is bigger than this one, or this one less than this one, so you have one tail. So this is a critical value. Okay, yeah, this is the F critical. And we will see how to find it from the table, don't worry. As I said, you can compare the F stat, which is bigger than the F critical. So I can say this is bigger than, yeah, this is bigger than this one. Can make this one bigger, also red, and make it bigger. Okay, so want this one, so it lies in the rejection area. So yeah, so we reject the null hypothesis, and the null hypothesis all the times talking about the equality, right, of the two variants in this case. So we reject this one, so they are not equal. Catch it? Also, you can use this one to get the decision. Okay, so you can use the p-value as we have done in the comparing t-test. So this one is less than what? Less than 0.10. That, yes, which is alpha, or the level of significance. So because it is less than, also we have the same decision to reject the null hypothesis. So if you use the p-value and compare it with alpha, or using the stat value and comparing with the critical value, in the same time, this one or that one, you have the same decision, right? Okay, so if you have this one or that one, and you can get the decision. So this is a F-test using Excel, which is very easy and very simple, right? Okay. So I'll give you this one in your chat. But you don't have the chi-square in the Excel. So if you have one sample, you have to do it by hand. Two sample, you already have it in the stat, in the Excel. Let's go for the normal steps by hand, if you would like to do it by hand. Okay, let's do it by hand. We still have time. Now, you have to write what? The name of the test. So the name of the test is using F test for 2 sample variance. Okay, so this is the main step you have, the first thing you have to decide, and then you go for step 1. Step 1, you're writing the null hypothesis, sigma 1 square is equal to sigma 2 square. The two variants are equal, and the alternative, I have to wait until I read the question. Do I have any keywords here to say greater than or less than to have one tail? No, he's just said, is there a difference? He said that only there is a difference. If he said this one greater than this one or that one less than this one, so in this case I will go for less than or greater than, right? But I don't have, so I go for the not equal. Okay. Step 2. In step 2, I have to determine alpha. Okay, alpha equal to what in this question? I catch it from my question here. It's also 10%, right? So alpha is 10% or 0.10. So this is what? Yes, from the alternative hypothesis, I have to decide that if I have not equal, so it will be 2 tail test, right? So in this case, remember you have 2 tail tests. So I have 2 critical value in this case. Okay. So I'll go for the presentation to show you how to use the table of this one. This is what we have written so far, and this is the level of significance. So I go for yes, I need 2 degrees of freedom. For the first sample, degree of freedom is the sample size -1. In the first sample, I have 7 items, so it will be having degree of freedom 6. The second sample having 8 items, so the degree of freedom of this one is 7. Okay. So yes, this is a F table. You will go for the numerator degree of freedom, and I prefer to go for the sample with the bigger variance, right? And the denominator, I will go for the sample with the smaller variance, right? Anyway, so you will go for the degree of freedom of the denominator, which will be the down, and the degree of freedom of numerator. So I have 7 and 6. I'll go for 7, 6. So I have 3. Remember, if you have 6 and 7, you will have a different value. So please be very careful. The degree of the numerator is the degree of freedom for the sample with a bigger variance. So you have to find the variance of the first sample and the second sample to decide it which one you will take it as a numerator, the one we have a bigger variance, and the degree of freedom of the other sample with smaller variance, right? So remember, if you go for 6 and 7 or 7 and 6, you will have a completely different value, right? Okay. Now, yes, the bigger variance, you have it in the numerator, right? And the smaller one, you have it. So this one is for what? For the sample with 8 items, right? So that you will go for, of 6 items. So the degree of the numerator will be 6. And the smaller variance for the other one, which is 8 minus 1, which is 7. Okay. Now I have the stat value and the critical value from the table. I can make my decision as I used to say, right? So I can say, we conclude as for the summary, there is a difference in the variation of the travel times along the two routes, right? Okay. This is a formula for the mean and the standard deviation, but no need for this one when you are using your calculator, right? This is a table. I like it for F. Here it gives you the degree of freedom of the numerator, and I know the numerator will be the sample with a bigger variance, right? And the degree of freedom of the sample of the denominator will be the degree of freedom with the sample with a smaller variance. Catch it? Now I can judge the stat value is the critical value. If the stat value bigger than critical value, so it lies in the rejection area, so I will reject the null hypothesis. Once you reject the null hypothesis, here it is, this is the two hypotheses, you reject this one, so you accept this one. Okay, so there is a difference between, they are not equal. It means there is a difference between the two population variance. What is the point of comparing two variants? Yes, I'll come back to the t-test. This is some exercise for you. If you go for the Excel, right, and you go for data analysis, and you would like to compare the mean using t-tests, right, you will see how many type of t-tests? 3 types. The first one, they call the pair two sample test. You have one group and 4 data, 2 data, right? But for the same group, right? And you get confused. Are you going to use assuming equal variance or unequal variance? Yes, F-test will solve this one. And you decided first using F-test, the two population having the same variance, equal variance or not. So it is very important to use F-test before you go for the t-test. This is our duty for today. I finish and I will leave for you the exercise. Try it by hand